Hi everyone, my name is Bhavashya, and in this lecture we will learn about more significance of our router ID. What is this type of LSA, our network LSA, and about the difference between our subnet mask, the usual subnet mask, and between our inverse mask. So let's begin. So the very first thing that we'll talk about is the significance of our router ID. So as you know that it helps us to identify from where the information or the LSA is being generated. Let's suppose we are looking in R2 and this is the router ID. Now, how will we able to decide if it is the received one or it is the LSA of its own? So for that, we first see the router ID. So this is the router ID. When we check in the R2 about the database, when we see the LSDB, this is what it is telling us. The router ID is 12.0.0.2. Okay. And when we look at the LSDB, it tells me that, okay, this is the link ID 12.0.0.2. So this is its own router ID, right? What it is advertising, its own information, and blah blah. The next up, if you look at this 12.0.0.1, so this is the received LSA, right? And this is what it is advertising. Now, if you look at the router one, similarly, first we'll check its own router ID. Okay, this is the one. And if you look at the second one, this is the received LSA from R2, right? Now, as you can see, we talked about that there are different type of LSAs, right? So this is the type 1 LSA, which is router LSA, right? That every And the fact about that was that every router generates a router link state advertisement or router LSA or type 1 LSA. Now the second type of LSA was type 2 LSA, which was network LSA, right? Now let's understand about it. For that, let me hmm. Okay, so as we learned, there are different types of LSA in OSPF. Now we'll learn about the network LSA. So this it's a type 2 LSA, and DR generates network LSA. Now what is this DR? We'll talk in detail what is DR, what is PDR, what is DR others, but in short, if I want to give an overview, so DR stands for designated router, right? If we talk about what is PDR, PDR is backup designated router. And the last one is DR other. So that is other designated router. So in short, designated router generate our network LSA. Now, if I ask you the question, does every router generates type 2 LSA? Generates type 2 LSA. So the answer will be false. And if you want to make this statement true, then we will say that not every router generates type 2 LSA. Now this will become true, right? Only designated router generates network LSA, right? Now let's revise of what we have learned so far. So the very first thing that we have learned was that RIP receives first-hand information, right? Because it generates LSA, then those all the routers generates LSA, then LSA gets maintained into or stored into our LSDBs, right? Now there are different types of LSAs in OSPF. Starting, there are 11 types, but this is what we'll immediately study here. The very first is router LSA. The fact about that is every router generates our router LSA. Then we have the second one, that is our network LSA. The fact about that is only designated router generates this network LSA, right? Now there is other concept, but before going into concept, let's revise the command that so far we have learned. Now, to enable our OSPF, what we used to do after going into config terminal mode, we used to type router OSPF along with the process ID, ranging anything from 1266655535, I guess. Yes. Right. After that, we used to give network along with the network address. And after that, we used to give inverse mask. Thing to note, inverse mask, not our IP, not our subnet mask. After that, along with that, we used to give area. And after that, we used to give what is the area. Let's suppose we are giving 0, so we will give this all small area 0.0.0.0. That says we are operating in backbone area or area 0. Now the other command that we used to see, that is show running configuration. Show running configuration. There we used to see which interface it is running or which network it is operating on. Right. After that we used to see show IP OSPF database like this. There we used to see what LSAs are this router generating or receiving, or what is the router ID or process ID, right? After that, we used to see show IP OSPF neighbor, where we used to see what are the neighbors that we have. Show IP, okay, all small. Show IP OSPF and then neighbor. So this is how we used to see who are our neighbors. After that, the command that we used to see was IP OSPF interface brief. Into brief. Yes, so it tells us on which interface OSPF is running, what are the neighbors that we have, or the cost is being accumulated to run OSPF, or the area it is operating on, or the process ID. Right, now let's see the difference between inverse mask and our subnet mask. For that, let me change the tab. Okay, the difference between inverse mask and subnet mask. So let's suppose um, this is the fast Ethernet that we have configured on router 1, let's suppose. And this is the subnet mask, slash 24. Now, in OSPF, we will go and we'll give the command network. This is the network 10.0.1.0. This is the network address, right? Along with the inverse mask. So for this, inverse mask will be this 0.0.0.255, right? Now, let's go backwards. Okay, now when we used to give IP address to our interface, this is what we were doing, right? This is the IP address 10.0.1.10 slash 24, right? And this is how we used to give IP address. And we used to give the IP address along with the subnet mask. So this was the subnet mask 255.255.255.0. That signals that, okay, this is the network part, right? From this 255.255.255, and this is the host bit, right? Or the host part, right? And okay, this is the IP address that we gave. This is the network address, and how many hosts we can go to? 1, 2, 3, 4, 5 till 254, right? This is the last host, and this is our broadcast address. Clear? Now, in a router 1 on fast Ethernet 0/0, this is what we give. This is the IP address, let's suppose we give. Now, to configure this, as we have learned already, we'll go to network and give the network address along with the inverse mask and then area and then on which area we are operating. So by virtue of this particular, inverse mask, what it says, when we give in the host part 255, all ones or 255, it says that this is my network, this is my network part. After that, every host from, 0 from 1 to 254, I can enable OSPF. So by virtue of this, we are able to give OSPF, or we are able to configure OSPF to this range of IP addresses, right? Only by this, right? So by this, inverse mask, 10.0.1.10 is enabled with OSPF. Not only this, we can also enable from this 10, or let's suppose 20, or let's suppose 5, or let's suppose even 254, right? So this is the use case of our inverse mask. Now if I want to give you another example, let's take router 2. Before taking router 2, so this was a command, right? Router OSPF with process ID 1, then network, and this is the network 0.20.0.0.0 along with the along with the not subnet mask, along with the inverse mask 0.0.0.255 along with the area and then area 0. Now if you look at this inverse mask, now tell me what IP address we can configure on this, let's suppose fast ethernet 0/1, as there is no IP address configured till now. So what IP address can we give to this interface by virtue of this inverse mask? So the IP address that we can give is 20.0.0. Anything ranging from 1 to 254, right? Because if you look at this, this tells me that okay, this is the network part and this all ones or 255 is my host bit, this particular. So I can give anything I want ranging from 1 to 254. 0 is assigned for our network address and 255 is assigned for our broadcast address. So I can give anything from 1 to 254. Right. So this was it for this video. I hope you enjoyed. See you in the next one.